Might you at any point accept it? Picture a grandiose occasion so tremendous that it creates shaded areas on Earth, even in sunshine. That may happen soon. Betelgeuse, a star in the Orion group of stars, is acting bizarre, proposing it could detonate into a cosmic explosion illuminating our sky like never previously. However, when will it work out, and what will it look like? As indicated by researchers, what mysteries could this occasion uncover? We should plunge deep into what's truly happening with Betelgeuse and how it could influence Earth and the entirety of the planetary group. Betelgeuse, around 650 light-years away in Orion, isn't simply any star. It's a red supergiant, unquestionably brilliant, north of 100,000 times more splendid than our Sun. Yet, what difference does it make? Betelgeuse is unique not just for its brilliance but also for its role in human culture. Named after the Arabic Yad Allah, meaning the hand of Orion, it has been noticed for quite a long time, directing voyagers and enrapturing stargazers with its ruddy gleam. Envision a star so enormous it could immerse our planetary group. Betelgeuse, at 10 million years of age, is much younger than our Sun, but its gigantic size means it consumes its fuel quicker, prompting a more limited life. Now, approaching the finish of its life, Betelgeuse is near the very edge of a grand finale, a cosmic explosion blast delivering incomprehensible energy and brightness. The last time Earth saw such an occasion was in 1604, with a Kepler cosmic explosion, visible even during sunshine for a long time. Cosmic explosions like Betelgeuse's are intriguing events, yet their leftovers offer important insights into the life cycles of huge stars. Betelgeuse's recent behavior has stargazers humming. Between October 2019 and early 2023, it went through significant darkening, grabbing the eye of stargazers worldwide. Although it appeared to return to normal by April 2023, subsequent months saw its brilliance flood by half, igniting conversations about its future. Might we at any point be on the cusp of seeing one of the universe's most sensational events? Betelgeuse's eccentric behavior suggests we may be closer than we think to experiencing its stunning blast. Stay tuned as researchers continue to observe Betelgeuse, unwinding the mysteries of our infinite neighborhood. However, why the abrupt change in brilliance? For what reason did Betelgeuse, one of the most recognized stars in our evening sky, suddenly throw a heavenly curve? Stars are not simply gleaming spots in our night sky. They are dynamic elements with life cycles, activity, and secrets of their own. For the majority of heavenly bodies, intermittent brilliance varieties can be predicted, similar to the rhythms of Earth's seasons. In its heavenly lifetime, Betelgeuse is timed in a reasonably predictable 400-day radiant cycle. Yet with its extreme diminishing, it appeared to rebel against its known nature, testing our comprehension of the divine marvels above. Now, you may be pondering, are we near the very edge of a heavenly disclosure? While the specific explanations behind Betelgeuse's anomalies are still under investigation, a compelling hypothesis has arisen. This hypothesis, revolving around heavenly activity and mass loss, proposes a tempting scenario. Envision Betelgeuse as a monster heavenly fountain of liquid magma, unexpectedly ejecting and regurgitating a huge amount of its matter into space. Past perceptions from the Hubble Space Telescope revealed that Betelgeuse has previously shot out a colossal amount of its surface material into the universe. This discharge, a titanic event, was 400 times the mass normally delivered during comparable solar phenomena, comparable to several times the mass of our moon. Such events can lead to the development of a thick dust cloud around the star, influencing its apparent brilliance and making it for a brief time harder to notice. Once this dust began to scatter or was driven away by the power of the star's radiation pressure, the cover lifted. This could explain its subsequent return to normal brilliance levels. One way or the other, these new events indicate a star that is not finished with its shocks. Many conjecture that Betelgeuse may be moving toward the twilight of its life, a cosmic explosion event. A cosmic explosion is a destructive blast, an astounding explosion of energy that can eclipse a whole universe quickly. This phenomenon occurs when there is a sudden change in the star's core. Such changes can arise if a star absorbs too much matter from an adjoining star, or, for Betelgeuse's case, it may be from the depletion of its atomic fuel, which overflows its mass into the core, setting the stage for a catastrophic breakdown. But what drives a huge star like Betelgeuse to its destruction? Born from the gravitational collapse of gas within atomic clouds, stars like Betelgeuse launch their process by consuming hydrogen in their core. This initial stage, known as the main sequence stage, goes on for millions of years and forms the foundation of a star's life. However, as stars run dangerously low on hydrogen, they advance, embracing new energy sources. For Betelgeuse, as the hydrogen drains, it begins to consume helium, leading to the development of carbon and oxygen. This change from the main sequence stage to the helium-burning stage is marked by the star's venture into a red giant. With time, as helium holds lessen, the star undergoes further evolution and shifts into other burning stages, each characterized by the fusion of progressively heavier elements. The greater the star, the faster these advances occur, given the tremendous gravitational tensions at play. Then, at that point, comes the peak, when iron begins forming at the core. Unlike lighter elements, iron doesn't produce energy when fused, so the energy generated isn't enough to resist the star's own crushing gravity. The star inflates inward and creates a collapse, followed by a huge rebound effect, resulting in the hazardous power of a cosmic explosion. So, is Betelgeuse near the very edge of a dangerous end, or just gnawing at its time? Recent research by Japan's Tohoku University suggests that the star may be in its carbon-burning stage right now. CHAP specialist Hao believes that the core could collapse years later as its carbon holds evaporate. However, not all researchers agree. Differentiating studies from Hungary's Konkoly Observatory estimate that Betelgeuse is still in the earlier helium-burning stage. The one thing that researchers do settle on, no matter what these discussions, is that Betelgeuse is scheduled to become the Milky Way's next cosmic explosion. Yet pinning down the timing of this event remains an astronomical guessing game, with wagers ranging from just a few years to 100,000 years. Amid these scientific discussions and theories about Betelgeuse's fate, one fact remains unchallenged: the very nature of our perception. At the point when we gaze toward the star-studded sky, there's an unobtrusive conundrum we often ignore. This paradox is rooted in the very nature of time and light in our vast universe. Stars and celestial bodies are so far away that their light takes an earth-shattering amount of time to reach our eyes. For example, the speed of light, while being a staggering 186,282 meters per second, still has its limitations. Consequently, the light from remote stars also takes time to navigate the immensity of space before it graces our sight. Looking at Betelgeuse, you're really seeing a display from 650 years in the past. To put that in context, when this light set out on its journey toward Earth, the Renaissance was just unfolding, and adventurers like Marco Polo were making their mark in history. Each observation we make of Betelgeuse is like looking through an inestimable time capsule, giving us insights into its far-off past. If, for contention's sake, Betelgeuse had already detonated in a glorious cosmic explosion, we would remain oblivious for another 650 years. So while we examine and predict its impending cosmic explosion, somewhere out in the vast universe, this grand event may have already unfurled. We're just waiting for it to cross existence until it reaches our eager telescopes. The ongoing disclosures around Betelgeuse have prompted intense conversations in the cosmic community, with examinations being drawn to another sensational discovery from recently, SN 2023X. This recently observed cosmic explosion happening in a galaxy adjoining the Milky Way helps many to remember the captivating elements and erratic nature of the universe. SN 2023X was remarkable in its own right, found several million light-years away, and it displayed an extreme showcase of brightness that quickly dominated its host galaxy. What made it especially intriguing to researchers and casual spectators alike was its uncanny likeness to what many foresee will be the destiny of Betelgeuse. The range, force, and fallout of the blast offered an enticing look into the cycles that these gigantic stars go through as they move toward the finish of their life cycles. For some, SN 2023X served as a preview of what's to come if and when Betelgeuse meets its hazardous destiny. The connection between these two heavenly occasions highlights a more extensive theme about the interconnectedness of our universe. Whether it's an adjoining star like Betelgeuse or a far-off cosmic explosion such as SN 2023X, these vast phenomena remind us of the dynamic and evolving nature of space. The realm of space exploration is filled with unknown regions and perplexing problems, and nowhere is this clearer than in our comprehension of red supergiants like Betelgeuse. However brilliant as they may be, these heavenly monsters hide some of the universe's most significant secrets. At a crucial level, the life cycle of red supergiants, although outlined, is accentuated with ambiguities. While we know that these stars advance from the main sequence stage to their grand supergiant peak, the intermediate processes are less grasped. These stages, which could involve wild disturbances in the star's core, are still subjects of intense research. Understanding these processes is crucial for comprehending how massive stars like Betelgeuse evolve and ultimately meet their end. As Betelgeuse approaches the conclusion of its life cycle, scientists are keenly observing its behavior and characteristics. The star's fluctuations provide insights into the underlying mechanisms that govern stellar evolution. For example, as it transitions through different phases of burning, the changes in its brightness and spectral characteristics can reveal the complex interactions happening within its core. The study of Betelgeuse also offers a broader perspective on stellar populations in the universe. By understanding how this particular star behaves, researchers can make inferences about other red supergiants and their eventual fates. This understanding is not only important for theoretical astrophysics, but also for unraveling the history of star formation and evolution in our galaxy. Additionally, Betelgeuse serves as a natural laboratory for testing models of stellar evolution. By comparing observational data with predictions from simulations, scientists can refine their understanding of the processes that drive stellar life cycles. This ongoing dialogue between observation and theory is a fundamental aspect of astrophysics. As researchers continue to gather data on Betelgeuse and other similar stars, they hope to unlock further mysteries about the universe. The interplay of mass, temperature, and chemical composition in massive stars like Betelgeuse has implications that extend beyond individual stars, influencing the formation of elements in supernova explosions and the chemical enrichment of galaxies. In conclusion, while Betelgeuse's future remains uncertain, its current behavior is a focal point of astronomical research. As we watch this iconic star, we are not only witnessing the life cycle of a single star but also gaining invaluable insights into the broader cosmic tapestry. Each observation adds another thread to our understanding of the universe and its remarkable phenomena.